So let's have a look now at how we might apply that kind of filter using LabVIEW. So I've cut in a bit of code here from LabVIEW. Let's have a look at this. This is a bit of code that does this filtering. So we take a sine function over here and we add some noise to it. We can control both the noise level and the frequency of the function. We'll have a graph here for that fundamental signal. So we'd expect to see a noisy sine wave here. We then take the Fourier transform and we're then going to split it into the real and imaginary parts, but we're also going to pass the same function through to this multiplication. So this is the multiplication step where we're going to times our filter function with our Fourier transform, so that we get over here a function that looks like this, where the noise here has been taken out. So this function here is this step. So the point here is that we need to know when the threshold here is for the function to be either 1 or 0. And that's what these limits do here. So we take the array, well we take the imaginary part of the array, so for a sine function we'll have a delta function like this and a delta function like this. Basically we want to know where that is in the array and where that is, and be able to control the onset of these thresholds, because what we really want is a function that goes up and down. So it goes from 0 to 1 and back down to 0 again. Remember that our function, our Fourier transform, is plotted from 0 to 1000 and not from minus infinity to infinity. Okay, so this function here selects the minimum point in the array here and the maximum point in the array and returns the indexes of those two locations. Then we take 80% of one of them, that's here, and 120% of the other one, which is here, and we use these to define limits when we create the array of all of these different values. So the false side here would be a 0 and the true side is a 1. And we use this logic control here, an exclusive OR gate, so that when the index of the array is greater than 80%, that's here, we call a 1, but it also, and when it's less than 120%, we also call a 1 here. Outside of those limits, we call a 0. We build up an array, which looks like this, and then we multiply it by the original function. And then we take the inverse transform to get back to the original sine wave. We have to convert here from an array with no dimension to an array with dimension. So we use the time step of the original time series. So let's have a look at the front panel to see this working. So we have a function here with a certain amount of noise. Take the Fourier transform, this is the imaginary part of that, multiplied by our step function, and then return the original function. So if we run this, we get a different noise function each time, so the result is slightly different each time. We can increase the amount of noise, and our ability to filter is reduced. If we have no noise at all, we have a perfect sine wave, Fourier transform, perfect sine wave again. So download this VI and have a play.